Hello everyone. Now we have to discuss the analysis of star delta connection. Okay. So this is the example. A star connected 220 line to line voltage to three-phase alternator supplied a balanced delta connector load having phase impedance of 15 plus J20 ohms. Means what? Star connected supply system is there and delta connector load is there. For that, line to line voltage is what? 220 volts, right? First we have to get the connection diagram, that's it. Okay, star is supply system, that's it. Next, coming to load, that is load is delta, right? Load is delta. Sorry, before that, that's it, right? This is V at an angle 0, V at an angle minus 120, V at an angle minus 240, right? This is what? 15, this is J20, 15, J20, 15, J20, that's it. We have a connection from R to R, Y to Y and B to B, that's it. This is star connected supply system and this is delta connected load system. This is impedance, right? This is impedance. That is Z, right? Z at an angle theta. We are having 15 plus J20, 15 plus J20, 15 plus J20. So load is balanced, right? We all know that before doing the analysis, first we have to write the voltage and current relationships in star and delta. Okay, we are writing R connected supply delta connected load, right? For star connected supply, we know that what is the relation between voltage, which is equal to root 3 times of V phase, and what about current IL, which is equal to I phase. For delta connected load, VL, which is equal to V phase, and IL, which is equal to what? Root 3 I phase, that's it, right? These are the relations between these two. We know that in case of delta connected load, the phase current, which is equals to what? The line currents or phase currents in star supply. Like that, in case of phase voltage in star connected supply, which is equals to what? Line voltage or phase voltage of delta connected load. Okay, now we can start the analysis. Given what is the voltage? 220 volts line to line. Given supply voltage VL, which is equals to what? 220 volts line to line. That's it, right? It is what? See, line to line voltage is 220 volts, but it is root 3 V phase, but the same amount of 220 should be same as phase voltage, right? V phase. So given VL as what? 220, it should be equals to 220 of that corresponding phase voltage of delta connected load. It is phase voltage of delta connected load system. Therefore, V phase is what? 220 volts, right? For delta. Given impedance per phase, which is equals to what? 15 plus J20, which is equals to what? 25 at an angle 53.2 ohms. That's it. So we have phase voltage, phase impedance. Obviously we have to get phase current, that is phase current, which is equals to what? Phase voltage by phase impedance, right? Now we have to get phase currents. Now we have to get phase currents in case of delta. In case of delta, phase currents are what? You all know that IRY, right? Between R and Y you have phase, that is V phase, that is VRY at an angle 0 by impedance at an angle 53.2, right? Which is equals to, what is the phase voltage, which is equals to what? 220 volts. This is 220 at an angle 0 by this is 25 at an angle 53.2, right? From this IRY is what? 220 by this one is 8.8 at an angle minus 53.2. See, we are having negative angle. We are having, see, negative angle means what? Means what? Phase current lags phase voltage by what is angle? 53.2 degrees. Now it's clear, right? Because this is VRY is taken as reference at an angle 0. With respect to that phase voltage, we have concluded that the current lags phase voltage by 53.2 degrees. Clear. Then next phase current, that is what? IYB, between Y and B. Obviously it is 8.8, that is minus 120 minus 53.2, which is equals to what? 8.8, which is equals to minus 173.52. We can call it as 8.8 in terms of positive angle 186.8. Just if you add 186.8 plus 173.52, you will get 360 degrees. That's it. Like that, IBR, which is equals to what? 8.8 at an angle minus 240 minus 53, right? Which is equals to 8.8 minus 293.52 degrees, which is equals to 8.8 at an angle 66.8 amperes. This is amperes. This is amperes. Okay. these are the phase currents. We all know that. See, we have phase currents, right? These phase currents in delta connected load should be equals to what? The line currents as well as phase currents in star connected supply. Phase current of delta connected load or phase currents of delta connected load are same as phase, which is equals to line, right? Currents in star connected supply system, right? Phase currents of delta connected load are same as phase line currents in star connected supply system. That's it. Now we have to get line currents. Phase currents completed. Now we have to get line currents. We know that in delta connected system, IL lags I phase by 30 degrees, right? 30 degrees. Therefore, in case of delta, IR is nothing but line current, which is equals to root 3 times of IR by, right? IL equals to root 3 I phase, which is equals to IR by is what? Minus 53.2 minus 30. Why it is minus 30? Because this line current lags phase current by 30 degrees. Clear? If it is lead, you have to put plus sign. That's it, right? From this, root 3 into IR by is what? We have IR by 8.8, right? Yeah, 8.8 into root 3. We have what? 15.21 at an angle minus 83.2. That's it. This is the line current of R phase. Like that, I by, which is equals to same value of magnitude, but the angle is what? There we have what? Minus 173.52 minus 30, that is 203.2 minus 203.2 amperes, or you can write just 360 minus this 203, we will get some angle, right? Or 153.2, you can write 153 plus 153.2. Okay, simple, you just add this 157, I think 157, right, amperes. Like that, the line current of phase B, which is equal to 15.21 at an angle 66.8 minus 30, which is equals to 15.21 at an angle, what is the angle? 36.8. That's it. Okay, load is bands means what? The magnitudes of IR, IY, IB are same. Obviously the summation of these three currents should be equals to 0. If you have any doubt, take calcium and calculate that summation, right? So we have completed the phase currents as well as line currents. We all know that the phase voltage is what? 220 at an angle 220 at an angle 0. Like that, phase current of V is what? Y is what? 220 at an angle minus 120. Like that, phase voltage of phase B is what? 220 at an angle minus 120. That's it. Yeah, now we have to get the phasor diagram. What is the supply voltage here? This is VR by, right? This is V by B, right? Like that. This is what VER completed. Then see that phase current which lags phase voltage by 53.2 degrees, right? See, 53.2 degrees, right? Now this is 90 degrees, 45, it should be approximately, let us say this is IRY. Okay, the angle between these two is nothing but 53.2, that is 5. Then what about IR, which is nothing but IRY minus IBR. Here I am providing only one sector only. We will get IR. See, IR is what? At an angle minus 83.2, minus 83. That is line current lags phase voltage by 30 degrees. See, this is IRY. So to get IR, obviously it is displaced from this phase current by 30 degrees. So we have to add just 30 degrees to this. Maybe for example, this is, say this is 30 degrees. That's it. This is what IR. See, from this you can say this is minus 83.2. The minus means what? Which is lags VRY by 83.2 degrees. Lags, minus indicates what? Lagging angle. But from this phase current, it lags 30 degrees. Always the phase displacement between line current and phase current in delta connection is 30 degrees. That is 30, clear. Then we all know that the phase angle between phase current and phase voltage is what? 53.2. Now it's clear. So from this we can conclude that if power factor is lagging, the angle between line voltage and line current is what? V line and I line is always 30 plus 5, right? If it is lagging, 30 plus 5, leading 30 minus 5. See, 30, what is the 5? 53.2, which is equals to what? 83.2 degrees, right? See, line voltage is what? VRY. Line current is what? IR. The angle between line voltage and line current is what? 53 plus 2, 30. Obviously, it is 83.2. Satisfied? So, this is the analysis of star connected supply and delta connected load.